Hello. Today we're going to talk about the distance formula. Just like in mathematics, there are tons of formulas to do a ton of different things. Today we're going to find the distance between 2 points. When we find the distance between these 2 points, we use the distance formula. The distance formula says my distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, it's all under this radical because we're taking the square root of this formula. Now, we will use this formula all year long. So we're going to find the distance of points all year long. Now, with this, there's a couple things we have to talk about. One, what is this x1 and x2 and where do we get it from? Just like back in Algebra 1, when you found the slope of 2 points, you had an x1 and y1. All that means is that I have 2 ordered pairs. This is my first ordered pair, nothing fancy. This is my second ordered pair. And if you remember, if you had a third one, you'd say x3, y3, just for a third ordered pair, nothing fancy. The next thing we're going to talk about is something called notation. These ordered pairs might be given points, like they might say, hey, this is A, and hey, this is point B. When we're talking about distance, we might see just the AB written like this. This means the distance of AB. If it has the bar over it, it means segment AB. There's a difference. This just notifies, hey, he's sitting there on my grid. This right here tells me how long is he. What's his length? It's the distance between 2 points. And sometimes when we find this formula, we're going to find it where that we have a coordinate grid and you might have to get the 2 points. Does not matter who you call point 1 and who you call point 2. What matters is that you're consistent inside the formula and solving it. So let's go ahead and let's look at some examples of what we're talking about. So, example number 1. So I want to give the ordered pair for A to be -5, 3. I want B to be -2, -3. So my first step says, hey, plug me into the formula. So my distance of AB is going to be the square root of x2 minus x1, so -2 minus -5 squared plus y2 minus y1 squared. All right, now it's just all the math. I strongly suggest solving under the radical first and then the last step doing the radical. Why? Because sometimes they're going to ask you to keep it in simplest radical form. Sometimes they're just going to ask you for a decimal answer. Just depends on what's going on. So let's go ahead and simplify under this radical first. So I have -2 plus 5 squared plus, my pen's not happy here, -3 minus 3 squared. So I have the square root of 3 squared. Notice I keep it in parentheses because it's always going to be positive. Distance cannot be negative. Only direction's negative. So here I have -6 squared because -3 minus 3 is 6. So now I have the square root of 9 plus 36. So AB equals the square root of 45. Now, sometimes they might want an exact distance. This right here would be what you call an exact distance because a square root does not have, you'd have to simplify him, and we could simplify him, and we'll go over that in just a second. We could simplify him into simplest radical form, but if I want an exact distance, you'll see it as a radical. If not, we just take it on our calculator. Now remember on Desmos, let me get my Desmos out real quick. Remember on Desmos where the radicals are. So here I have my Desmos calculator. So I want to go ahead and I want to do the square root of 45. So remember, this is the square root right here. I put him in first. I put the little 45, and then over here shows up my answer, about 6.7. It doesn't matter where you round to, you'll be told. Usually tenths or hundreds, never the whole number, never, ever, ever. So he's about 6.7. Now, if I happen to ask for an exact answer, let's just say, we're pretty smart, we can handle this. We're going to simplify this radical, if you remember back in Algebra 1. When I go to simplify this radical, I need to know what makes up the square root of 45. So I know when I taught my students, I broke it down to its prime factorization. So 45 is what? 9 times 5, so it's 3 times 3 times 5. Because it's a square root, 2 come out, so it's 3 square roots of 5. We will go over that some more if need be in class. For right now, that's just kind of review. Maybe we'll do some reviewing on simplifying those radicals as a warm-up one day. Right now, we're just making sure we can use the distance formula. So decimal answers is okay for what we're doing. Okay, let's look at number 2. Okay, work this while I'm working this. Let's have these ordered pairs. So A, I want to use -4, 1. B, I want to use 3, -1. All right, let's go. So let's plug it into our formula. So again, we have x2 minus x1 squared plus y2 minus y1 squared. Just plug it in. Second step, simplify the parentheses. So I have 3 plus 4 squared plus -2 squared. So I have 7 squared plus -2 squared. You probably could have simplified that a little quicker, but that's okay. 49 plus 4. Square root of 53, which when I put it into my Desmos, I get about 7.3. Final answer. This just means about. It's a rounded answer, nothing fancy. If you put equals, it's not wrong as well. It just means it's approximate. All it means. All right, and our last quick example for today. Last quick example. I want you to work with me while I work it as well. So I'm going to give you the point E, which is -7, -2, and F, which is 11, 3. All right, you work it while I work it. When you're done, check your work here. If you have any questions, please let me know. Have a great day.